So this is a system we should find. At the beginning it was at rest, no velocity, and someone releases the system. Of course, this object will move downward in this direction approximately. This wedge inclined plane will move to the right because there is only one option. It cannot move itself to the left. If you assume that this inclined plane moves to the left, it means this small object should move upward, which is impossible in real life. Something cannot move by itself upward because it needs more energy, more force, because we have a gravity downward. So it will try to move downward. It means this inclined plane will move to the right. There is only one option. It cannot be stationary because no friction. If we have a friction, yes, there will be two options. This system can be at rest because of friction. It may halt, but at the moment there is no any friction, so it will move, and it will inclined plane will move to the right. Small object will move downward approximately. So first of all, it looks like dynamics question. So we need to draw a free body diagram, basically forces acting on each object. Let's start with inclined plane. Downward we have 2mg, its mass is 2m. To the right we have a tension. To the right again we have one more tension. And in this direction also we have a tension. Tension is everywhere same because rope is massless. When rope's mass equal to 0, force on the rope everywhere will be same according to the Newton's second law. And also we have a reaction force upward, let's call it N1, and we have a reaction force between these two objects perpendicular to this surface, so let's call it N2. Let me think, is there any other forces acting on inclined plane only? We are considering only inclined plane at the moment. I think that's all. We showed all forces acting on inclined plane, and we know that this inclined plane can move only to the right, and let's call its acceleration, I don't know, A. Let's call it A. We know that this inclined plane is moving to the right, so let's consider all forces acting on this object in horizontal directions. So we have a T, and this tension forces horizontal component, which will be T times, here is alpha, cosine alpha, and this reaction forces horizontal component, it will be sine alpha according to the vector. So to the right we have T n sine alpha, one more T. So basically 2T plus n2 times sine alpha. These are all forces acting to the right, and to the left we have a T cosine alpha. This should be equal to mass of the inclined plane times inclined plane's acceleration. So this is our first very important equation formula, which is coming from Newton's second law. Resultant force equal to ma. This part is resultant force in horizontal direction. This is a ma. Of course, this equation is not enough. Here we have, I think, three unknowns: tension, N2, and acceleration. It means we need two more equations at least, maybe more equations. So now let's consider the small object. Let me draw it separately somewhere here. And again, free body diagram. Downward we have mg, upward we have tension, and in this direction we have a normal force N2. And this object is moving in both directions, in horizontal and in vertical. Let me explain it. Let me try to explain it. So this inclined plane moving to the right, this object will move approximately in this direction. So at the end, let me use different color. inclined plane will be in this position. This object will be here. So this is a trajectory or direction of this small object. So as you see from this picture, this figure, this object is moving in two directions. Downward, we have a, let me draw it here, AY, acceleration in vertical direction. Also it's moving to the left side, let's call it AX. We have two accelerations because it's moving in two dimensions, basically. So let's write this tension and the normal force in terms of components. So this angle is alpha. It means we can remove it and write it in terms of components. In this direction we have t cosine alpha. Upward we have a t sine alpha. Same logic we will use for n2. Upward we will have n2 times sine, not sine, cosine alpha. Cosine alpha. To the left we have a n2 sine alpha. So now we have all forces only in vertical and horizontal directions. Now we can apply Newton's second law in two dimensions. In vertical direction, down it will move downward because mg is greater than these forces. That's why it's moving downward. So resultant force in vertical direction, mg minus tension sine alpha minus n2 cosine alpha equal to mass times acceleration in vertical direction. Now let's apply Newton's second law in horizontal direction. We know that this object is moving to the left. It means this force greater than this force. That's why it's moving to the left. So resultant force in horizontal direction, n2 sine alpha minus t times cosine alpha equal to m times acceleration in horizontal direction. So pay attention, we have two more equations, in total 3 equations, but let's count again how many unknowns we have. Tension, N2, A, AX, AY. We have 5 unknowns, but we have 3 equations. So it means these 3 equations are not enough to solve this problem. We need to come up with extra additional equations. Now I think, now we know that we need more equations, and these equations we believe is a relationship between A, AX, and AY, relationship between accelerations, which is basically kinematics. So let me draw it here. This is the initial position of the inclined plane, and this is a small object. Let me use dot. And this is the initial position of the system. After some time, this object will be here somewhere. It means inclined plane's position will be like this. Of course, they will be moving. As you see, this is the trajectory direction of the small object. It will move in this direction. So we have this kind of right triangle. We know that this angle equal to alpha, or this angle is equal to alpha. We know only this information. So now let's consider one of these right triangles. There are so many right triangles. This is a right triangle. This is a right triangle. This is also right triangle. There are so many right triangles. So let me use this big triangle. And according to this big right triangle, tangent alpha equal to the opposite side. Let's call it y. This is the height, y. We should divide by this distance. Let's call it x. And this x actually equal to summation of these distances. So this is a, pay attention, this is the end of the inclined plane. So this is the distance that inclined plane moves to the right. Let's call it x1, and this red line, actually this is a displacement of small object in horizontal direction. Let's call it x2. So as you see, this x actually equal to x1 plus x2. So let me repeat. Y is a distance or displacement that this small object moves in vertical direction. x2 is a displacement of small object in horizontal direction. x1 is a displacement of the inclined plane to the right. And we know that y equal to 1 over 2 ay times time square, because initial velocity equal to 0. x2, this is a small object's displacement in horizontal direction. So we need to use horizontal acceleration. x1, this is for inclined plane, its acceleration is just a. So when we use all these informations, at the end we will get this kind of formula equation. Tangent alpha equal to y over x1 plus x2. As you see, everyone has a 1 over 2 and a t square. So at the end we will have this kind of equation. A plus ax. So this is our, we hope, final, last useful equation. Here we have 4 equations, but 5 unknowns, so we need one more equation, basically, logically, to solve this problem. So we know that rope is inextensible, basically length of the rope is constant always. From that logic we can find some other relationships. So here this is a initial position of the rope, for example, and after some time it will be like this. So here this is one of them approximately. So initial length of the rope, upper part, let's call it L1, this part is height, this part is L2 initially. So length of the rope initial equal to L1 plus H plus L2. And finally this is the end of the inclined plane. We said that it moves to the right for x1 distance. It means this part also moves for x1 distance. Now let's write length of the rope, final length of the rope. So basically this part equal to L1 minus x1 plus this part same h. This length equal to L2 minus x1, and the plus this is this length of the rope, which is basically according to this triangle, right triangle. This part is h, this part is alpha, this angle. So this length equal to h over sine alpha. So L1, L2, h. So at left side we have a 0, at right side we have a negative 2 x1 plus h over sine alpha, or we can say 2x1 equal to h over sine alpha, or we can say 2x1 times sine alpha equal to h. Also it means x1 is distance that inclined plane moves, and inclined plane's acceleration we said a. It means we can write it in terms of acceleration. 2 times a times sine alpha equal to h is a acceleration in y direction. So let's copy all our equations in one place so we could decide what to do further. So now we have enough equations to solve this problem. This is the question number 4. This is the question number 5. And also we can call it question number 6. And we, from all these equations, I found that A, there might be mathematical mistake, but I think this should be correct answer for A, acceleration, by using all these formulas: 7 sine alpha, cosine alpha, 2 cosine alpha sine alpha, plus 7 cosine square alpha minus cosine cube alpha. This is a value for acceleration, just A. And we can find velocity. Actually, velocity is square root of Vx component, x component velocity square plus y component velocity square, and here this is 2axx2 plus 2ayh, and by using all these equations, everything is given. At the end, final answer will be 2ha, here 5 minus 4 cosine alpha over 2 times sine alpha. So A is here, so we need to just substitute, and this should be final answer. These problems, math is a bit long, and you should be very careful.